G. Now, if we have a disk, I'll raise the temperature of it. Any impact on there's a radius. It is rotating with an angular velocity omega, having a radius say like a r, mass m, initial temperature theta 1 degree. I'll raise the temperature. We know the disk will expand, no? Naturally, the disk will expand. Anything will happen to the quantities. R dash or anything. So initial radius is R1, final radius is R2. Temperature, okay, let me write T1, theta again, you think angular displacement. Anything will happen to the angular velocity. Mass should remain same. So we know area, moment of inertia, I equal to mr square. Di equal to m2r into dr. 2mr, dr what we can write? R alpha delta theta. So therefore this will become mr square 2 alpha delta theta. Mr square by 2, moment of inertia of the disk. Let it be as it is. No. So this mr square by 2, I'll write it back as di. So look at di by I, 2 alpha delta theta. Moment of inertia in fact will change. Then we are going to supply heat, no? When body absorbs heat, what actually happens here? It will absorb heat and nothing but what happen, due to that temperature will increase. So first of all, what do you mean by temperature? Shall I say the random motion of atoms about their mean position? That's what the temperature, no? So as you increase the temperature, what actually happens? The random motion of atoms about their mean position will increase, or the vibration of atoms about mean position will increase. So if a body is at high temperature, what does it mean? The atoms will be vibrating more rigorously. And it will be random, not in synchronized here. So what is a modern definition of temperature? The degree of random vibration of atoms about mean position. There is a modern definition. So how you define temperature? It's a measure of degree of randomness motion atoms about their mean position. Okay, that one. If the more randomness is there, the temperature is said to be I. This is a modern definition, what we define here. So body at 10 degrees, body at 20 degrees. Molecules in the body at 20 degrees, what will have more randomness vibrations. Random less, not random lesser, randomness. Degree of randomness motion of atoms about their mean position. This is a modern definition. Okay, now definitely here it will expand. So therefore we have supplied it. Each supplied any net torque, 0, no? Net torque is 0. So therefore what will happen to angular momentum should be conserved. So initial angular momentum should be equal to final angular momentum. So what is the basic definition of angular momentum? I into omega. So net torque is 0. So therefore delta L will be 0. So delta L is equal to I delta omega plus omega delta I. I'm interested in that angular velocity. So we can write it as delta I by I. You have delta I by I. What it is? 2 alpha delta theta. So look at now, what will happen to omega? I got negative sign. What does it mean? Kinetic energy increase or decreased? Angular velocity increase or decreased? The new angular velocity, we can write it now. Omega 2. Now you look at, now what do you expect? Angular velocity increases or decreases? So a disk is rotating. If you increase the temperature, what will happen to its angular velocity? It's going to decrease, is what he's saying. It's going to decrease, it's telling. But sir, we supplied it, then angular velocity should increase because we supplied energy. Moment of inertia is increasing. Angular velocity will be decreasing. Moment of inertia will increase. You see, di by I. Sir, what will happen to the kinetic energy? Let's see. Anything will happen to kinetic energy. So what is the initial kinetic energy? How you write? K1 equal to I1 omega 1 square by 2. K1 by K2. I1 by omega 1. I2 by omega 2. What is I1? mr1 square by 2. What is I2? m2 mr2 square omega 2. So therefore this will become r1 by r2 whole square. R2 will be greater than R1. We know it. So what is the expression for this? R1 1 plus alpha delta theta whole square. What is omega 2? Just now we wrote it, no? Or omega 2 by omega 1. Let me write it. Omega 1. See, everything we have to begin with the mathematics here. So K1 by K2. So what do we get? This is 1 plus let's see what do I end up finally. So 1 minus 2 alpha delta t. Higher order terms, let me neglect. This will be 1 plus 4 alpha delta t. 1 minus 2 alpha delta t plus 4 alpha delta t. Higher order terms will be neglected. So 1 plus, is there any change in kinetic energy? So what is K2? K2 should be equal to K1 binomial expansion, or I'll write one more step. Yeah, you'll get confused again. Check calculation once. I think just see once, because the end equation I want to conclude. Yeah, fine. Okay, this further K1. Now tell me what will happen to kinetic energy. Will be less than, no? Will there be any change in kinetic energy? Yes. They may ask you fractional change in kinetic energy. So you must be able to manage it. So in rotation mechanics, I can bring no rod rotating, I'll supply it. What will happen to moment of inertia, angular velocity, what will happen to kinetic energy? They may ask you all these things. Even in rotation mechanics, I can introduce this. Okay, shall I think we'll stop it here. Tomorrow, Saturday, I'll discuss few more problems. That one after main paper discussion, we'll continue. Few more topics are there. We'll continue. Few more numericals I had to cover it. Okay, thank you all of you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Please,
Thank you.
please put effort in